Hello, everyone. Welcome to the sixth episode of the DevStandup. Today we have Kristo around as our guest. Kristo is a data engineer and co-founder of the data engineering consultancy Curione and a lecturer of the data engineering at the University of Tartu as well. With the hands-on experience on data engineering and the academic perspective, Kristo will walk us through the similarities and differences between software engineering and the data engineering, from the tools and skill set to the mindset that shape each discipline. So without further ado, Kristo, the stage is yours.
Thank you so much for having me. It's a pleasure to be here. And thank you for the nice introduction. Yes, my background is in data engineering. I've also been a software analyst for a few years, and that's why I really want to discuss some of the aspects of the software engineering versus data engineering mindset that I have seen. And there are, of course, if anyone Googles, you will find a lot of information about these comparisons. I think one of the first ones and a very nice one is this from Ryan Swanstrom. It's 9 years old, but it's still quite relevant today, how maybe the software engineers and the data engineers compare. So typically data engineer shares some of the capabilities with a software engineer and also with a data scientist. And then there are some aspects like the data warehousing, which is typically the data engineer's domain. But this comparison, of course, is very much on the technical stack. So today I want to talk more about the mindset aspect that I have seen and how these compare. But just so everyone is on the same page, I will discuss some of the shared foundations of the software engineering and the data engineering perspectives, because there definitely are many similarities. They are both called engineering or engineers if you work as one. So naturally there is an engineering mindset. You really try to look at the world from a perspective that you try to fix and improve things. And one of the core aspects of that is automation. So with both software engineering and with data engineering, you want to focus a lot on the automation aspect, because it's not something that you want to do just once and then do it again later. I mean, at least in a similar pattern. So what ties to automation is also reproducibility, which is, I think, important both in software engineering and in data engineering. If you do something, you really want to make sure that it works every time, at least as much the same way as possible. And one way to validate that, of course, is observability, again, which is a very similar foundation in both software and data engineering. And one aspect that I have seen is that both of these domains, the work there never ends. So with software engineering, you typically build a software product, but over time, the requirements start maybe changing a little bit. There is definitely a maintenance that needs to be handled. Things around the software start changing, and that's exactly the same with data engineering. So you build data platforms, but the pipelines change and the requirements start changing from the business side. But with so much of the foundations as shared, then there is this question that I have seen a lot, and this is something that at the moment, like Ali introduced me, I identify myself as a data engineer, and often data engineers are just put into the IT stack, especially from business people, but also in IT people. It's like some kind of a corner of IT. There is some truth to it, and as we can see from these shared foundations. But I mean, there is this saying that if it looks like a tomato, then then is it a tomato? And especially if you compare maybe British English and American English, so it's a tomato thing. I would say data engineering is not like a tomato of software engineering. It's more like tomato and potato. So maybe both of them are edible, but from a different perspective. And that's what I want to cover in today's brief session. And this is based on, I have roughly 10 years, actually a bit more than 10 years of experience working with different data warehouses. I have helped build data platforms for companies of various sizes. And I've been also teaching data engineering and doing research in data engineering for quite a few years. And one of the key differences that people have to consider from a mindset perspective is what is the output of this engineering endeavor. So if you consider software engineering, then typically how software engineers or how software engineering comes to be, you have some kind of manual processes, or maybe any kind of processes. Maybe some of it is automated, but you have a need. You want to improve a business process, and you want to do this from a functionality perspective. So the software needs to have some kind of functionality. In data engineering, well, the data engineering in a very brief sentence, it's about making sure that you have systems in place that support decision making based on data. So the data needs to be trustworthy, and it needs to be there when the decisions are made. Decisions not only by business people, but these days also a lot about the decisions are made by algorithms if we consider data science and machine learning. But the issue of trust is the same. So for data, the point is that the numbers are correct, and the focus of the output is on trust. So even though maybe both the software and data engineering are building some kind of systems, then the actual output, if we consider this from a mindset perspective, is different. So with functionalities, you can quite easily understand if it works or not. Trust is something more vague. And of course, you need to understand then that also there are different expectations actually from the business side, and maybe also different personality skills that become relevant when you work as a software engineer compared to a data engineer. And especially in data engineering, this saying goes around quite a lot. So what goes in comes out. So that's what builds the trust. So you need to make sure that your data pipelines, even if they are working perfectly fine, I mean, from a software perspective, you would say that, okay, this platform is top notch, everything, no errors, every day it's working fine, every hour it's working fine, but it's what's inside. That's the question, what's inside. So is that actually trustworthy? Which leads us to another key difference comparing software and data engineering, and that's the input side. And here I would say that with software engineering, usually you have quite a bit more control over what you are doing, because usually you would have full control over the code and software. I mean, of course, you are dependent on the business requirements and what is actually needed in this business process. But and you might have external APIs, you need to do integrations, etc. But it's a bit more structured in that sense. The core aspect of data engineering, data warehousing, building data lakes in general, it's about combining all of the data sources, if possible, of the company, and even external data sources. So you have a lot more dependence on very different stakeholders. So you might have multiple sources, and these are typically constantly changing. So if you're starting to build really enterprise data platforms, it's going to be a very different playing field in how this communication goes on. And again, this is an aspect where I think data engineers need to have quite a bit more communication skills and make sure that they are actually aware of the landscape much more than maybe software engineers. So there is more of this juggling around and keeping an eye on multiple aspects of what is going on. You have less control and you need to just be more aware. And the third aspect is that's maybe not covered enough if you search for this information online, is how bugs appear in systems. So again, with the software, I mean, we are working with functionalities. So with the software, usually bugs are immediately visible, at least in production. You know, you will have some customers who keep getting errors or report that these functionalities are not working as expected, assuming that it's an important software for people to use. And again, this is because functionality, it's quite obvious to see whether it works as expected or not. With data, it's more challenging, and it can stay hidden for a very long time. And there are many of these anecdotes of how these numbers don't add up, and also how these issues in data have been going on for very long periods of time, because no one is so actively looking at each part of this data. We are considering only the trust aspect, so we don't, someone needs to be there to validate it. So there definitely can be days, weeks, or even months before sometimes the bugs in data engineering are discovered. That's actually what I wanted to cover today. So I will just briefly reiterate these challenges and also offer some paths forward, what I see are trends in the industry, and also from a maybe wider perspective. So the output aspect, how do we control that we have actually this trust in data engineering? And to scale this trust, there is this word that is getting more popular, but it's still very loaded. It's data governance. And I would focus mainly actually just on one aspect of this, which is the growing importance of data catalogs. So data catalogs are places where actually you store all of the metadata about all of the data of your organization. So you have all of the systems, all of the tables, and even all of the columns defined. And ideally, you also define the data lineage. So if there are visualizations that you have coming from your data warehouse where data is integrated from multiple systems, then all of this runs nicely, and you can visualize this in the data catalog. Another aspect is the input. So here there is something that's been going on in software engineering for a long time, but it's now also being more active in data engineering, is this perspective of shifting left. So you need to detect issues earlier on. And if you remember that, yes, we have these many systems that we are dependent on, then there is actually a growing importance of data contracts. And data contracts is similar conceptually to API specs. So typically at the moment they are laid out as YAML files, and there are already companies working in a way that all of these integrations from a data engineering perspective are defined in these data contracts. Why is this important? Because previously, giving data warehouse or data lake pipelines access to a source system just meant that maybe we create some views in our software database, and this is queryable. But of course, the software has changes, so this impacts the downstream data pipelines. But with these data contracts in place, it becomes more obvious for the software engineers as well when something might break for the data engineers down the road. And the bugs aspect, so we have an increase in data quality checks and testing, and there is actually a growing importance of automated tests. So in the last 5 years or so, data engineering has started to adopt a lot more practices from software engineering. Previously, it was not so common to use really sophisticated version controls and CI/CD pipelines, but this is becoming more and more prevalent in data engineering as well, and this is definitely the path forward as well to detect these trust issues that and these bugs that might occur in the data. Of course, what's more complicated, of course, is that someone needs to figure out what is actually a bug in data, because in functionality, again, it's usually if you click this button, will that happen? If this thing happens in the system, do these things get triggered? With data, it's more complicated from the perspective that someone needs to give meaning to that data. And that's all from the presentation side. Just some links if anyone wants to contact me or read some of the posts that I sometimes post. Happy to connect and happy to do some Q&A.
Thank you very much for your presentation, Kristo. I just have some 2 or 3 questions if you have time.
Yeah.
Yeah. So one of the like first I wanted to also, maybe this is about your background. You have mentioned your background was in software engineering, and what was the story or the event that made you switch to the data science, data engineering? Like how did you get started to it?
I started in data engineering, switched to software engineering for a while as an analyst, and then switched back to data engineering. I was exploring a little bit because my background actually from my bachelor's and my initial work was in marketing and media. So there I already worked with data, but it was mostly in Excel, and I did some programming in VBA. But and then I switched to data engineering because that was the first job that I got about 10 years ago, working for a financial institution. But then I wanted to see what software engineering looks like. I enjoyed some aspects of it, but to me, this I don't know why exactly, but I really love data. So maybe this there is just much more numbers and finding these patterns that I enjoy in data engineering than maybe software engineering can provide for me.
Good. Thank you. Like the second question I have is, this is like regarding to the last slides we had. As you mentioned about the differences, like on the slides about the inputs, bugs, and the shift left approach that's recently happening. So, do you think the data engineer should be also aware the scalability, like the concern about the scalability and the upstream dependencies, or that is like just purely the job of the software engineer to maintain or figure it out?
Just to clarify, you mean like the scalability of the source systems from a data engineering perspective? Yeah. I think it would be good for the data engineer definitely to be aware of that, because if we imagine, especially often in the beginning of starting data integrations, you might want to do some kind of historical data loads. And if this is a database that is not very scalable, then it's quite easy to clog the source system. This is also something that often happens. There is one anecdote I know that is about 17 years old, or from a year from the late 2000s, when also for a financial institution they were having these nightly jobs, but the nightly jobs took 25 hours to run. So you run it every night, but it keeps getting delayed, and this also, of course, has an impact on the source systems as well. And so definitely the data engineers need to be aware of that. And ideally, you move either to a CDC, which is a change data capture type of framework, so you get every change that happens, or you really agree with the software engineers what are the how to do these incremental loads. So when is the okay time to do these loads, and what to keep in mind.
Okay. Well, for my last question, I want to ask it because like also your current being as a lecturer on the academic field, for the future data engineers that are just starting out, they're always hearing like, what is the current hot thing? Like now it is machine learning. Before that it was snowflakes. Before that it was like this whole Looker, Athena, those kind of things, like the serverless integrations. So today, if a student or someone that is interested in data wants to start on data science, what would be the best foundation according to you, like since you have both experience from the lecturer side and also the implementation side from the industry side? So
as core skills, I would say that still it's SQL and Python. And with Python, you don't need to know about the software engineering aspects that much. It's just that you understand how Python works, because there are so many tools and frameworks that rely still on Python, so you wouldn't be scared of it. Regarding tools, I mean, these change almost every few years, like you mentioned. Like what are the current hot tools? As a data engineer, I would, especially now with these large language models helping us consume information and produce some kind of output, it's much more important to understand the aspects of how these frameworks actually work and what to consider. Because like one challenge that I've seen, and this is not only in the recent years, but it's been throughout my career, is that there is a hot topic like big data. Big data has been a hot topic for maybe 10 or 15 years already. So people try to work with Hadoop, and people try to work with Spark and Databricks. It's not often needed. If you only have like 20 or 30 gigabytes of data, then go for something simpler. Even with 100 gigabytes of data, you probably can use just one machine that has a lot of RAM if you need to process this data every day. But if you had this distributed systems, yes, it works, and Databricks makes everything super simple, but it's often just not needed, because I mean the optimizations there get also much more complex. So people want to go to the gym, 300 meters down the road, and then they buy a Tesla to do that. It doesn't always make sense.
thank you for your great answers. Well, that wraps our sixth episode of DevStandup. A big thank you to Kristo for sharing his insight and experiences and bridging the world of software engineering and data engineering and their differences. And if you'd like to be our next speaker and share your journey or ideas with the community, please fill down the form below. We would like to hear from you. Well, until next time, bye for now.